Hi, welcome to this video. Today it's a new project and I have a huge pile of parts on my table because today we will build a computer. This will be the Galaxia Plus computer. It will not be emulation, it will not be running on FPGA or a microcontroller. It will be a real retro computer built around a Z80 CPU.
The Galaxia has been a do-it-yourself computer in Yugoslavia. It was designed in 1983 and it was published in an electronics magazine, and the man who designed it, his name is Voja Antonic, expected that a few hundred people would build it, but eventually 8,000 people ordered the parts and built their own Galaxia computer, so this was quite a success. The machine itself had specs that were quite similar to those of a Sinclair ZX81. It was powered by a Z80 CPU, it had no color, no sound, with only 6K of RAM, which is a little more than 1K of a standard ZX81, and it had no dedicated graphics chip. The CPU had to do all the work to generate the video signal. So, all in all, it was quite a low-tech machine. 2 years later, an improved model was introduced. It was the Galaxia Plus, and it had high-res graphics, more RAM, and a sound chip. Now, in recent years, interest in the Galaxia slowly began to increase again. It began with Tamás in Slovenia, who wrote his diploma thesis on the project of redesigning the Galaxia using modern electronic parts, because some of the original parts from the 1980s were no longer available. Then the Galaxia Plus was equipped with an SD card interface, and it is this latest evolution that we are going to build. I found this on a web page, which unfortunately is no longer available, but you can find all required files on my Google Drive. You will find a link in the video description. The circuit has been designed by PVV and the PCB was designed by FIFAN. When I got interested in building this computer, the first thing I did was that I searched the web to see whether other people had already built this Galaxia Plus replica, but I didn't really find a lot of information. I found a few people who had built the original Galaxia, but that was all. And then I found the web page of Goran in Serbia, who had built the original Galaxia in 1984, and recently has built exactly this replica. However, on the photos on his web page, I noticed a few small differences to FIFAN's original design, so I sent him an email, and I think now it's time to say big thanks to Goran, who not only answered all my questions, but also helped me with some basics on electronics, because he's a true expert in that field, and I'm definitely not. Goran initially didn't get a picture, and the SD card wasn't working, so he made some experiments and finally got everything working. Now, let's take a look at these modifications. First, the video output. Use a piece of wire instead of R16. Use these modified values for R17 and C19, and do not mount C20. The audio input output. Most of you will never use this for loading or saving programs, so you can leave out these components if you want. However, I would still recommend you to mount these parts, because the tape output can be used for playing sound on the otherwise silent Galaxia computer. The SD card interface. Instead of the diodes VD4 and VD5, use a voltage stabilizer. Mount it like this. It's the black part in the center of the picture. It looks like a transistor. And you need to connect the center pin to ground. And if you take a look on the underside, this can be accomplished with this short piece of cable. The power supply. It is recommended to use a laboratory power supply. Start with 5 volts and reduce the voltage until the picture gets stable. This should happen at about 4.35 volts. Alternatively, you can use a mobile phone charger. Use a diode to reduce the voltage. If the voltage should be too low, then use 2 Schottky diodes. Be aware that when the voltage is too low, the picture will get unstable when the screen is filled up with characters or graphics.
So this is the main board, which has been designed by FIFAN, and the Gerber files have been made public, and so I ordered 5 of these boards in China, and I think it's beautiful. And this will be the PS2 keyboard adapter. This is my own creation, only the PCB of course, the circuit has been designed by PVV, and this is my first ever PCB I've designed, and I've used Print Layout for this, which is not free, but I think it's a good program for beginners. And I've tested everything 1,000 times in Sprint Layout, and I hope that everything will be eventually working fine. So I think this should basically be a routine job soldering this. It will of course be a lot of work because there's so many soldering joints to do. The only part that could maybe be a little tricky will be this SD card connector, which is sort of surface mounted. And another problem is it has these two little plastic pins, and on the board there are no holes for these. So you can use either a sharp knife to make these little dents, or in my case I'll use an electric drill. But be aware of this connection. This is a ground connection, and you might break this when drilling here. So in case that you should break it, you have to add a wire as a workaround to connect these pins again. Let me just show you this crazy idea that I had to mark the exact drilling positions. I put the SD card connector on the scanner with the underside facing down. Then I mirrored the image, made it a little lighter, and then I copied it a few times here. Then I printed out everything in real size. Then I would cut out this outline, put it on the board, and then I'll use sticker tape to keep it in position, and then I'll use a needle or something to mark these two pins. And with that I think I should have the exact drilling positions. So now we have these two little dents here. The smaller one doesn't look pretty because I didn't get the position right at the first attempt. So now when I put this SD card connector here, it snaps into position, and I think these pins are almost perfectly aligned. So I think we are now ready to start soldering, and we'll start right with this SD card connector. As I've said, this seems to be the most difficult part of all. And here's the result. I have to say that this looks better than I had expected. I've cleaned the flux with isopropyl using a toothbrush and a piece of toilet paper for polishing. These three pins here were very difficult to solder because they are so close together. I've checked with the multimeter whether there is an unwanted connection between these adjacent pins, but everything is fine, there is no connection. So we are now ready to solder the rest of the board, and as usual the lower profile parts go first, and I think we will do the IC sockets next. So all IC sockets are soldered now, and this actually wasn't too difficult. It was actually a fun job, in my opinion, and now will come the harder part, which is soldering all these small parts, these resistors, capacitors, and so on. So let's do that now. I've made a lot of progress now. I have soldered all resistors except for R17. I just noticed that I had ordered the wrong type, so I'll have to get a new one. And I've soldered all capacitors except for the 4 electrolytic ones. I will do these last. And there's the cords. There's 3 diodes, pin headers for the keyboard, and this expansion port. So there's only a few more things to be soldered and then it will be finished. However, I have just noticed that I've made a terrible mistake. When I was soldering the socket for DD20, I have bent one pin of this socket and now it is here instead of being where it's supposed to be. So I will now have to unsolder this socket again. Okay, here's the socket and here's the bent pin. So this socket is now soldered again and we are now ready to do the rest of the parts. Okay, the main board is complete now. All the parts have been soldered and I've cleaned the flux from the underside. And before we populate these IC circuits, we will make a simple test with the multimeter. We will connect the power here and then we'll check for each socket whether there is the correct voltage between the ground pin and the VCC pin of each socket, just to rule out that we made any stupid error. Our main board will need 4.3 volts to operate, and so I made this little power supply. I made this on a breadboard. I'll make a proper solution as soon as I know that everything's working. We have a micro USB breakout board here, connected to a mobile phone charger. And here's the ground pin, and here's the VCC pin. And we see that this gives us about 5.10 volts. The ground pin is connected over this wire to the negative pin of this cable. And the VCC pin goes through this diode, and we can check the voltage here, and we see that this diode drops it to about 4.7 volts. I've noticed that when it's connected to the board, it drops it even more to about the 4.3 volts that we need. So we can make our final check here. The positive pin must be on the inside. Be very careful not to swap the polarity. And we see that here we have the reduced voltage. With the power supply connected, we can now check whether our ICs will all have power. And normally it's like this. The ground pin on these ICs is usually on the bottom right pin, and the VCC pin is usually on the top left. And here we have about 4.37 volts. And we can check the same here. And here, and here, and I can tell you already that I've checked all these ICs and the voltage was always present. This pin configuration is valid for all ICs on our board except for DD9, which is the CPU, and DD13. DD9 uses pin 11 for VCC and 29 for ground. And let's check DD13. Here we have ground on pin 10 and VCC on pin 5, and here we have our desired voltage again. And now it's time to solder the PS2 keyboard adapter. This should be an easy job after what we have done already. The lower profile parts go first, so we will start with these resistors. Okay, that was it. Here's the complete board. Here's the PS2 plug. The micro USB plug, I've soldered it like this. I've put it on pin headers. I don't know whether there is a better solution to do this, but it is very stable anyway. And here we will connect two ribbon cables to XP2 and XP3 on the main board. Okay, here's a mobile phone charger connected to our keyboard adapter. We can now quickly check whether our ICs will have power. D1 uses the usual configuration, so we have about 5.10 volts, and D2 uses pin 5 for ground and pin 14 for VCC, and here we have our desired voltage again. Now we will have to program two EEPROMs for the main board and two microcontrollers for the PS2 keyboard adapter. For that I have acquired this programmer that plugs into the USB port of your PC. It's a TL8662 Plus, which is an inexpensive standard model that can handle many vintage EEPROMs, but also modern microcontrollers like the ATmega or the PIC. However, you may encounter EEPROMs that are not supported by the programmer software. With some luck, you will be able to program them by disabling the ID check or by selecting a different but similar EEPROM made by some other manufacturer from the list. But always make a read check first. We will first start with the EEPROM for DD11, which will hold the system RAM. We put it in like this, with the notch facing to the front, and we lock it with this lever. We will first have to select the EEPROM type in the programmer software, and so we take a close look at what type of EEPROM we have here. The manufacturer is Intel and the model is D27128.
We first have to select the manufacturer of our EEPROM, which is Intel, and the model is D27128, the DIP28 version. Before writing anything to the EEPROM, we should first make a read check. So we click read, and it reports an ID error. And the reason is that probably this particular type of EEPROM is not correctly supported by this programmer's software. So what we can do is we can disable the ID check and try to read it once again. And this works without any problem. So we will now try to write it like this. We will now load the image that we would like to write onto our EEPROM, and this will be the ROM file. So we open this bin file, and now it's in the buffer. And now we click Prog and Program, and this will take a while. And it says that it has been successful. I just noticed that I used the wrong file for writing the EEPROM, but the good thing is that it doesn't matter, the result is the same anyway, and I'll show you why. You see that there are two files in this package, and if you intend to program a 16K size EEPROM, then it would be a good idea to use the 16K file and not the other one. I don't know what the 64K file is for, but the first 16K of these two files are binary identical, so we still have a correct result. But I would have expected a warning message or something from the programmer software in such a case. Now here's a simple way to double check whether our EEPROM has been correctly written. I've just restarted the programmer software and I'll disable the ID check once again. And with the EEPROM still in the socket, we will now read the content of our EEPROM. Okay, now it's in the buffer. And we will now save this file, and we will save it to the same directory where our EEPROM files reside. And we will use the same file name, but we will add the postfix check to the name. Okay, now we have saved it. And now we will enter the Windows command prompt. And we will go into the directory where our ROM files are. And we will now use the built-in comparison tool FC, which stands for File Compare. And we will now compare these two files. And it says that these two files are binary identical. So we are now 100% sure that our EEPROM has been correctly written.
So now we have programmed both EEPROMs and both microcontrollers. I have made little stickers that I put on the EEPROMs so that they don't get erased by sunlight. And now we're ready to populate all IC sockets. Okay, our two boards are complete now. All sockets have been populated, and I think we are ready for a first test. I made this little reset button. It goes here, and it's not very stable, but I think it will do the job. For connecting these two boards, I've built these two ribbon cables, but the problem is that they are not long enough, and this particular type of cable is currently out of stock. Let me show you what the problem is. Okay, this cable goes here. I've marked pin 1 everywhere with a red sticker, and the same here. Okay, this is XP2, so this goes here, but the problem is that we need to flip the cable over. And the same with this cable. Okay, and I think you see what the problem is. And I've even cut this cable in half in an attempt to make it more flexible, but this didn't really help. So I think the best solution will be to have this adapter upside down and use it like this for our first test. Okay, this is the moment of truth now. I have set up everything. Here's a PS2 keyboard. The TV is on. Everything is already under power except for the main board. And I will now connect this power cable and let's see what happens. And I can't believe it, we have a picture. Okay, let's see whether the keyboard is working. Okay, the keyboard is not working, but I think our main board seems to be functional. Okay, I've made a few experiments now, and I think I've solved the keyboard problem. The first problem was that when the main board is connected to this mobile phone charger, there is no reaction from the keyboard. But when I connect it to this one, which gives either more or less voltage, the keyboard is working. And the second problem was that the keys were not mapped correctly. And obviously I've made an error in marking this pin 1 for XP3. Pin 1 must be here. So I just needed to flip the cable and now the keys are mapped correctly. I've now connected the Galaxia to my LCD TV, and the picture is quite good actually on the LCD screen as well. We will now try whether the SD card slot is working, and for that we first need to type in this command. Okay, now we get to this command prompt, and here we can type dir to list the files that are on the SD card. And we can load one of these programs just by typing its name and pressing enter. And I will try this little game. Okay, now it's loaded into memory and we can start it by typing run. By the way, the author of this game is the maker of the original Galaxia computer. And here we have this beautiful little game. Okay, so our SD card slot is functional. We will now try whether the Galaxia Plus mode is working as well. This machine always starts in standard Galaxia mode, and to activate the Plus mode we have to enter this command. It's very similar to the one we had before, it's only using a different address. And here we are in Galaxia Plus mode. And we can now enter the command we had before to activate the SD card. Okay, now we can list the directory once again. And we will now change into the Plus subdirectory that I made. And here are a few programs for the Galaxia Plus. And let's try this little game. And here we have a Galaxia Plus game. Okay, and this one, as you can see, is using high-res graphics. So, Galaxia Plus mode is working as well.
I finally found the reason why the keyboard initially wasn't working, and it had nothing to do with the voltage of these chargers. Let me show what the problem was. When I had connected both boards to separate USB chargers, the keyboard was not working. But when I had both boards connected to this double USB charger, the keyboard was working. I don't have much knowledge of electronics, but I immediately got the idea that maybe these two boards need to have common ground. And so I tried it once again with separate chargers, and then I connected ground between these two boards, and suddenly the keyboard is working. So the conclusion is we need to connect ground between our two boards. And to do this, we can use the unused pin 1 of the XP2 keyboard connector, and we can connect it to pin 1 of the D1 chip. And on the underside it looks like this. I've just added this short piece of cable, and I've already updated the Gerber files, so this workaround will no longer be necessary on the PS2 board. But on the main board we still need to connect pin 1 of XP2, and we can connect it to the ground pin of DD14, and on the underside it looks like this. It's just this short piece of wire that we need to add, and with this modification the keyboard will be working with separate USB chargers too. Finally, let me give you a few tips for building your own Galaxia Plus computer. Here are a few photos. Mind the orientation of the diodes. Here are VD2 and VD3. You see the black marking indicating the negative side. And here's VD1. And on the right you see pin 1 of XP3. I've marked this pin with a red sticker, and I did the same with XP2 in the background. And here we see everything from above. Here we have pin 1 of these two keyboard connectors. And here we have the PS2 adapter. You see that I've also marked one side on each of the two ribbon cables, so that I know where pin 1 is. But don't worry, nothing can happen if you should accidentally connect the keyboard cables in the wrong way. The keyboard will simply not be working, but it won't do any damage.
So that's a successful ending to this project. I hope you enjoyed watching this video as much as I did building this computer. And for the ending partless, I've typed in this little basic program. So that was it. Thanks for watching, and until next time, goodbye.